Hello, welcome to the Debian room of the Capitol de Gregory Colpart and Lecour are going to talk to us about how we do apt upgrades for a few servers the Evolix way. Thank you.
Bien joué. For 20 years, we have been installing and maintaining server, mostly with Debian. Currently, we maintain around 1,000 Debian server. Overall, it's just few shell scripts that we are improving bits by bits, many small details to make our upgrade work easier, faster, and safer. This is what we are going to tell you. Then we are talking about security and point release upgrade, not major upgrade. Major upgrades are a completely different story that might tell another time, maybe submitting a talk at DebConf 25.
Obviously, we don't have all our servers tracking the stable release, the stable branch. And here is approximately how it spreads. And as you can see, we go from Debian 6, very old, to the latest Debian 12. And stable and old stable account for more than 50% of the total, which I think is quite good. But we still have some old servers. The servers with Debian 6, 7, and 8 will probably never be upgraded. It's too late. They will die eventually. Servers with Debian 9 and 10, we make an effort to upgrade them to 11 or reinstall them with 12. And we use a variety of different repositories for our packages. We have our own internal mirror for everyone. It's on our own domain name, but it's just a mirror. We also have a public repository for some packages that we publish. The .NET one is an old one, a legacy one, and the .org, we rebuilt it a few months ago. We also use Debian official repositories for security and archive. And since we've been subscribers of Frixian for extended LTS for nearly the beginning, we have made our own mirror to ease on the load for them, and it's faster for us. A few servers are still using the old one. And even if we strongly favor official Debian repositories and Debian packages, we have to install some packages from third-party sources. And here are a few examples of the repositories that we sometimes use, like the Elastic Stack for FileBit mostly, but Elasticsearch and Kibana. Docker, it's not JS, sorry. Some packages to help dealing with hardware RAID controllers or other stuff. And some other that you might recognize, like Docker, PostgreSQL, and France.
Then, how to upgrade them all? With a big number of servers, we have to find a special strategy. There is a different way to do this. Of course, the manual way, we can connect over SSH one server a time, but it's not possible for a lot of servers. We know, of course, unattended upgrade tool, but it's too risky to us to do this blindly. We can also use a fully automated upgrade with Ansible, but like an unattended upgrade, it's too disconnected to react quickly if we need. We discover an old tool, apt-data. It's very interesting, but it doesn't scale for a lot of servers. And then we make the Evolix way our own mix between manual and automated tools.
To make things fast and reliable, automation is often a good way to go. Like we can update the states for apps or download packages that can be automated easily. We can do some safety checks, for example, disk usage and disk space. When we need to install new kernels, we need to check beforehand.
Yes, mostly for kernel, for disk space.
Yeah, and also we use some LXC containers sometimes. So we need to do the same thing as we have done on the host system inside the LXC containers. But the main constraint is to remain in control. If something goes wrong when we upgrade a server, we need to already be there, already be on the servers. That's why Ansible is not a valid solution for us. We need to be aware and in control. Outside of fairy tales, not everything is perfect, obviously, and textbook architectures are very rare. We might find some services that have trouble restarting, especially third-party services that are not as well built as Debian managed services. Some clients may need to remove some processes from the pool before doing some maintenance, so we have to have some coordination. And some server-to-server dependencies might also impose a specific order of operation, like shutting down the application before shutting down the database. So that's why we need to inform our clients in advance.
Then we need to inform our clients, mostly by email. Then we send a list of upgradable packages, a list of daemons that will restart, and so give them the opportunity to put one or several servers on hold. Then it is our workflow is consistent from week to week. This creates habits for our clients and users, and after a couple of times there is no surprise. They know what happened and when it's happened. Tuesday morning is for preparation and email notification. Tuesday afternoon is the slot for first upgrade on non-critical server, for example, pre-production. The main slot is Thursday evening with the most critical server, and third slot is Friday morning with critical server for clients who prefer the Friday morning. Let's focus on Tuesday morning. Then we apt-get updates. We download package locally on the server, and we inform clients by email.
On Tuesday afternoon, just a few hours after the preparation, we utilize this slot to be in advance regarding the most critical servers, and that's about 200 to 250 servers. If there are issues with some packages, we might catch them and resolve the issue before going to the biggest batch, the biggest group. There is an example. In August, there was an issue with the kernel, with a big regression, and we did some upgrades beforehand. We noticed it, and it got corrected, and in the meantime, we held the process.
On Thursday evening, 2 days later, this is the biggest slot. Sometimes I do it. We have about 2 hours window to upgrade most of the servers, including the most critical ones. That's about 700 of server. 700 of server. And it usually goes, in the best case, it's 30 minutes.
On Friday morning, it's a slot for some special servers. Like we said, some clients want them to be upgraded after the night tasks and before the busiest hours of the day. Some servers are also in the North America time zone, so it's still the night for them. And that's about 50 to 100 servers. How often do we do this? We try to do it. It could be every week, but in practice, it's 1 to 3 times a month. We try to avoid holidays for our comfort, but also because our clients might not be as available as possible. So the preparation is done by a script that runs on every server every week on Tuesday morning. It's called list upgrade, and it begins by getting its configuration from a central URL. It's a very simple text file. In this one, we decide if upgrades are enabled or disabled for this week. If we don't do anything by hand, it's disabled. And if we enable it, the process starts. In this file, we have allow and block lists for releases and for packages. That means we're able to ignore like stretch or like bookworm if we want, or we can ignore a specific package. Usually we do everything, but it's a possibility. And if any error is made during this process, the server will be disabled, will have no upgrade this week, like a network issue, a problem, updating the states, anything, and it's off for this one. So we want upgrades. We need to tell in advance our clients what's going to happen, so we need to freeze everything. We need to guarantee that the list will stay the same between Tuesday morning and when the server is upgraded. That's why we tell app to store its states in a custom location, not the usual one. And we reuse those states when we upgrade. And we also download the packages in advance to guarantee availability, mostly, but also to speed up the process.
And timing matters. Initially, we launched list upgrade script at 9:42 on every server, but we have issue with boundaries on our mirror because downloading package on 1,000 server is difficult just on one mirror. Then just we randomize the execution time between 6 and 10 o'clock, and we are good.
Yeah, much less errors.
For upgrade session, we'll launch the final script on a workstation. Final script parse list upgrade, sync email from a dedicated box receive Tuesday. It parse all message to detect host name, to build list of server for Tuesday, Thursday, or Friday. If a client wants a hold, we just delete related message in the inbox, and we launch the script just before upgrade session. Then the script gives us up-to-date batch to do.
When we have to upgrade 600 or 700 servers during a session, we cannot upgrade them exactly at the same time. So we use a terminal multiplexer. We can choose between cluster SSH or Xpaint, And we can also choose the size of the batch that we want, depending on the screen real estate we have. When we start a session with like 18 connections on a single window, we can type the upgrade command only once, and it's run in all the servers on the same window. But if we need, we can zoom on a specific one and type commands just for this server.
I prefer to use cluster SSH. You have a discrete terminal per server and a command text input. It's very simple and efficient. There is small issue with copy paste and special character. And you depending on your window manager, you need fine-tuning to prevent Windows overlap. Then a screenshot with a cluster SSH with on 15 server, just after upgrade. You can see color, and we will explain just after.
As for me, I prefer to use Xpains, which has the full power of Tmux and some default configuration to help doing this multiplexing things. You have a single window. Whether with CSSH you have as many windows as servers, so you have a single one with multiple panes, and you can do everything you can do with Tmux inside. I think it's more robust, it's more rich, but it's also much more complex to use. So that's what it looks like. It's obviously almost the same. You have less Chrome, you have less space, and if you move the window, everything moves at once, but it's a multiplexer.
So upgrade time. Thursday evening is a real deal. Then we launch 8 batch of 18 server. Then we launch the first batch, and we don't wait. We launch second batch, third batch, and 8 batch.
Yeah, we go up to 8.
Yeah. After each group, we make a pause. We check monitoring. We fix issue if needed. Optionally, we make a longer pause to fix or work around some problem. If shit really hits the fan, we can interrupt the session completely and prevent further damage. In 5 years, we interrupt 1 or 2 times. Yes. And we repeat all the process 4 or 5 times. A focus on monitoring. During upgrade, we enable a special mode for monitoring with a higher frequency for check and notification. The on-call team is relieved and alert go to the person responsible of the upgrade, and then any issue is managed more reactively.
We have shown you how we do things in parallel, but let's zoom on what happens on a specific server. So the script, the command that is run, it's also a script. It's the third one. It's called MAG. MAG means upgrade in French. And so if all goes well, this is a single command that we have to run. Everything is done inside this one. We run apt commands with Debian frontend non-interactive, so everything goes. If there is an error, we can see it, but we are not interrupted.
And we are sure there is no debconf question or...
We keep many logs of every command that we run, and also we copy apt term log and apt history log, so we can review afterwards what happened. And we try to limit the verbosity of the output, and we use term colors for clarity. and you will see how it looks. So it's a slightly sped up version of the script, but you can see that we typed the sudo password, then it shows the list of the packages, then it dealt with the kernel, restart a lot of services, then goes through over the LXC containers, and then the recap in the end for the host system and LXC containers. So it deals with kernel cleanup at first.
The first step is a kernel cleanup. We check for available space, and we remove useless kernel. We keep the running kernel and the latest kernel. We use a script based on a bool size matter script for the kernel to do that.
We have modified it, but yeah, it's inspired by this one. When it's time to really upgrade the packages, we do this on the host system, like the base system. Then we go through any LXC container that might be running on the server, and everybody uses the same custom state files that we have saved on Tuesday morning. And also, since we don't want any surprise, we run apt commands with apt upgrade with no download and no remove. When a service is upgraded by its package, it's usually restarted, but some libraries require a restart of dependent services. Like if you update the libc or libssl, you have to restart services like Apache, bind, HAProxy, anything. So we use need restart in batch mode to know exactly what needs to be restarted. We do the restart manually. It's not manually by hand, but the script does the restart and displays the status afterwards so we can see if everything restarted well. This is the output of need restart in batch mode. This is a special way of showing information, and it's compatible with updater protocol. That's what it uses inside. But you can see that we have to restart ODD, dbus, Getty, Muninode, etc. After upgrading packages and containers, the script does some bookkeeping, like sending email notification to the clients and users, but also to us, sysadmins. It triggers a script, a homemade script that is some kind of clone of etc keeper. It didn't exist back then, but it does the same. It commits changes in /etc. And some traceability tasks for us.
Then we are near the end. When the script exits, if all is green or all is good, we often check with a page up in cluster SSH to verify all status of services quickly. If needed, we can focus on a specific terminal. And also, if we want to check the responsive of a terminal, we can make a Control L for clear or just enter. And after that, we just leave the terminal.
Again, that's what the script does. The same animation as before.
But we don't see that. We launch, and after we rewind to see the video.
Usually at the end, when we have 18 very small windows, we just see the last 2 lines, and if everything is green, then it's okay. We can leave. So to review, it's a homemade thing. It improved step by step, and we have. We think there are a few good spots. So it takes 1 or 2 hours for a week to upgrade 1,000 servers. That's quite good. That's acceptable for us. We can do this, like I said, 1, 2, 3 times a month. It's a lot of automation. Maybe we can do a little bit more, but it's quite much, and the rest leaves us in total control. if there is any issue, we can react immediately and do what we need. Sometimes what we need to do is just a simple manual restart for a service. Sometimes a sysadmin did a mistake, changed the configuration, didn't restart the service, and now it's broken because there was a mistake in the configuration, so we can have a look and fix it. And sometimes it's a poorly made third-party package that doesn't want to restart, and we have to do some things manually. Things that we see that might be improved. Today we don't have any real strategy for reboots. This process ignores the necessity for any reboot. So we have to work on that. We think we give insufficient information to our clients regarding what happens inside LXC containers. For the host system, it's really nice, but that is insufficient.
We don't have a lot, but we need
not nothing, but yeah. And it's mostly a single-person workflow. We can collaborate, but it's difficult to do this really efficiently with many people. And maybe that's stupid and obvious, but a batch is as slow as the slowest server because we don't want to close each window as soon as they are finished. We want to have a big view and close when everything is done. So it's a little bit of an annoyance, but it's not very important. And since we hide apt logs, it's cool for very limited verbosity, but we have to get them if we need. So that's how we do this. We have like 3.5 minutes to have questions or ideas on how you do this.
Thank you.
Thanks, that was interesting. I was a little surprised that you didn't treat each LXC container as essentially a separate machine. Can you share why you decided to treat them all as subordinates of the host? Because
this process has existed much longer than LXC containers in our situation. So it's an add-on, it's an afterthought that we have to deal with LXC containers. Maybe we could do this separately, but we don't want to have an explosion of email like 10 or 15 emails per server. Some clients have like 100 server with us, and we don't want to make too much.
And we don't use a lot LXC.
Yeah, that's not much.
Only for PHP version on a web server, then we don't have a lot of LXC containers.
Fair enough. Thanks.
But essentially, the script does something on the host system and then does the same in a rootfs or attached in the LXC container. So in practice, it's almost the same.
Any other question? How much time?
Thank you for your presentation. Are your scripts available somewhere?
It is not right now, but not because it is a secret, but because it was not really interesting, and we thought it could be, so that's why we presented this. But
so now you are somehow forced to publish it after this presentation. And my second question is maybe something that was missing in your introduction was how much the pool of servers you are upgrading is different. Are there like a complete different set of are they running a complete different set of software and packages, or are they somehow similar?
We try to be very homogeneous between servers, and we try to limit the differences. I wanted to show you. Yeah.
We have a lot of we have 100 clients. Then it's very, very different. Then we need have all terminal are different situation. Then that's why it's complicated to we need focus on all terminal.
Yeah, I wanted to show that, but that was not your question. Yeah.
Last question.
Thanks for your talk. I also really like the email notification for clients. That's really important. I only upgrade a bit more than 100 servers. I don't have email notification because I maintain them mostly. But what I've done is I change the background color depending on the architecture. Because I have several AMD64 and i386 and ARM64, and I have a different background color for
We
that.
have only one. That's much.
But you could do the
simpler.
same with web servers.
We have one non AMD64 server, so it's just one. Thank you very much, and let's keep talking afterwards if you like. Thank you.